All right, welcome and thanks for joining 6.2 Law of Cosines. So I've got a whole bunch of formulas written down there. Start writing them down. I'm just going to be explaining sort of what they are. So all of these are really just iterations of the law of cosines. You could really just memorize one of these. You don't have to go and specifically think of them as different things. This is just my law of cosines. Now, what we're saying in these following two is just that really like the variables don't matter entirely, or they're sort of interchangeable. So like what you call A might be the same thing as B, and then you just have to adjust to the other sides accordingly. So the way I like to think of it is what this would really mean in a triangle. This is saying in a triangle, if I wanted to find a side A, then A squared is equal to the squares of the other two sides, regardless of letter, the sum of the squares of the other two sides, minus 2 times the product of the other two sides, and the cosine of the angle in which I'm solving for the side, which is sort of weird to, I don't know, think about that. But again, just sort of looking at these letters, if I'm solving for A, I will have cosine A. And everything else is just the other two sides. So it's the sum of the sum of the squares, and then twice the product. If I were to solve this equation to isolate cosine A, I would get this equation. And what does this help me with? Well, if I wanted to know then what is angle A equal to, it would be inverse cosine of B squared plus C squared minus A squared over 2BC. And again, that's just really solving this equation. So again, looking at this, if I'm talking about angle A, it's equal to inverse cosine of the two other sides squared and added together. So the sum of the two squares of the other sides minus the square of the side across from the angle I'm looking for over twice the product of the other two sides. Now, you can go and if you wanted, memorize all 6 of those. But that's pretty rare. You might as well just memorize one and get down the idea that these letters are interchangeable depending on the triangle. If I'm solving for B, then I'm using this equation, but it really is just the same as this. All right, so law of cosines. When do we want to actually use the law of cosines? In the given information, if you are given 3 sides, so side, 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 that is a case in which you want to be using the law of cosines, because that's going to allow me to solve for one of the angles. If I'm given side, angle, side, so the angle here has to be the included angle between those two sides, you would want to be using law of cosines. Once you do law of cosines one time in a problem, you no longer have to use the law of cosines. The cool thing with law of cosines is you could use it for every side and every angle. But it is more work, and it creates a little bit more opportunity for us to make mistakes. So typically the way that we'll do it is shoot for using law of cosines one time. After that, recognize that you can do law of sines. Law of sines, however, there's some little bit of a concern that I'll talk about in a second. But law of sines, when it's useful, if I have angle, side, angle, if I have angle, angle, side, or if I have the side, side angle, which is that ambiguous case being possible. So there might be 2 triangles in this case. That was terrible. There we go. There might be 2 triangles. There might be 1 triangle. There might be no triangle. Right triangle trig, just stuff that you were already used to all the time, is only useful if you have a right angle. Now there is a little caveat to the law of cosines. Because we only want to do it once, what you want to do is be specific in the thing that you solve for in law of cosines. Specifically, you want to use it to find the largest angle first. So if you have like a case like side, 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 you ideally want to use law of cosines to find the largest angle. And that's only if you plan on using the law of sines afterwards, because you can run into some issues with law of sines. You won't run into issues with law of cosines, though. All right, and then we just have some examples. Those are always super fun. They'll, in a different video, they'll look more examples. And then just Heron's arrow. area, ooh, gosh, reading today. Heron's area formula. So the Heron's area formula is area is equal to the square root of S times S minus A times S minus B times S minus C. This may look familiar from geometry. If not, don't worry, it's not too bad. Where S is equal to essentially the semi-perimeter. So you add up all the sides and divide it by 2. That's again called the semi-perimeter because it's half of what the perimeter would be. So find the area of a triangle with the following dimensions. This example I will do here. I know that A equals 10, B equals 18, C equals 22. The first thing I need to do is find the semi-perimeter. 10 plus 18 plus 22 over 2. That's going to give me 18 plus 22 is 40, 50 over 2 is 25. So area is equal to, and usually we use a capital A, so I'll go back and fix that because I already have lowercase a meaning something else. Square root 25 times, and then 25 minus each one of these numbers. So I'll have 15, 7, and 3. If I multiply all that together and then simplify that radical, I get 15 square root 35. Again, that's, after simplifying the radical. All right, that's it for what I'm covering in here. Make sure that you have this idea of Heron's area formula down, and make sure that you go listen to those examples, especially if you don't really remember law of cosines. It's going to be important for you to see a little bit of them before you get started. Otherwise, feel free to get started working on some of that bookwork.